Hello and welcome to another episode of North Country Ham. My name is Aaron, KD2RSS. I appreciate you stopping in and checking out the video. This is going to be part 6 of my video series for studying along with me for Amateur Extra class. Going along with this video today being Super Bowl Sunday, I'm recording it instead of going live because I didn't really think there'd be much chance of any kind of participation live. So with that, let's kind of get into it and go from there. Alright, welcome back. We don't want to spend too much here getting into it. We'll get right into it and go through my question pools, continue on where we left off in the last video, going through the Gordon West 2020 to 2024 Amateur Extra. This is I'm taping back over. I did most of the questions on that, so you'll see some of them already highlighted because I went through and had to do a voiceover on it. I lost video or audio on that, so we'll be going back through it rather quickly with that, so bear with me, and with that, let's get started. Alright, so as you can see here, we got our extra class book, Gordon West. We'll kind of go to we're in the second part of the question pools, the skywaves and contesting, and we'll just pick up where we left off. We left off here on rural activity stuff, so continue on. Skywaves and contesting. Which of these emission modes is best for auroral propagation? Again, so you'll see that we've already answered some of these on these questions up through the end because I lost audio, so I had to re-record over. So I'm redoing this through the questions, so that's why it looks like I've got them already answered. So which of the emission modes is best for auroral propagation? Is it A, CW, B, single sideband, C, FM, D, RTTY? Bouncing a signal off the auroral is difficult. CW plays the best opportunity for someone hearing raspy sounds coming into the receiver. On many auroral contexts in CW, we don't even hear a tone, only a short and long rushes of superimposed noise. There's an audio CD you can get to go along with this. You can hear examples on there. So the correct answer is A, CW. So let's go on here, and it kind of shows a nice little picture of the auroral photo from Chip and Janet Margalelli in Coldfoot, Alaska. I spent a little time up in Alaska. I enjoyed it up there. Got to see some of that stuff out on the water quite regularly. Why does the radio path horizon distance exceed the geometric horizon? Is it A, the E region skip, B, the D region skip, C, due to the Doppler effect, or D, downward bending due to density variations in the atmosphere? You see we've already got it answered as D. Let's go through the reason why. The VHF-UHF radio horizon is approximately 15% farther away than the geometric horizon. This is because the lower portion of the VHF and UHF wavefront is slightly slowed by our denser atmosphere, allowing higher altitude wavefront to travel slightly faster, causing the entire wavefront to bend slightly beyond the geometric horizon. Listen to the audio CD to the sound of the long-range VHF, UHF over the horizon signal. So the correct answer is D, and it's because of downward bending of the signal because of the density variations in our atmosphere. So we'll go on to our next question here. By how much does the VHF UHF radio horizon distance exceed the geometric horizon? Well, we just heard on the last one, it's about approximately 15% farther. So by approximately 15% of the distance, by approximately twice the distance, approximately 50%, or approximately 4 times the distance. So it is, and as we saw in the question before, stated 15% further. So radio waves bend slightly over the horizon because of differences in the air's refractive index at higher altitudes. You can calculate your approximate VHF range to the horizon with the formula d miles equals 1.415 times square root 2 times height in feet. Determine h, the height in feet of the station you are wishing to communicate with. Calculate the distance to the horizon and add the two answers together for your rock-solid communication range. Depending on local weather conditions, a 15% to 30% range enhancement over the geometric horizon will usually take place at VHF and UHF radio frequencies. So 15% further. All right. Tropospheric propagation of microwave signals often occurs in association with what phenomenon? A, gray line, B, light discharges, C, warm and cold fronts, or D, sprites and jets. So as you can see, we answered it warm and cold fronts, and this is why. Warm and cold fronts from large surface reflectors for VHF and microwave signals, as well as plain old light. Answer C. And it kind of shows tropospheric ducting here a little bit on the, to kind of make it make sense here. All right, atmospheric ducts capable of propagating microwave signals often form over what geographic feature? A, mountain ranges, B, forests, C, bodies of water, D, urban areas. Ducting works best for the two walls forming the duct that are flat and parallel. This is most likely to happen over a large flat surface such as a body of water, but can also occur over a large expansive desert. So C, large bodies of water. VHF and UHF signals will travel freely within the red and orange areas of tropospheric ducting. See Hawaii at the bottom left. Work at tropo every summer for days on end for 2 meters through 5.6 gigahertz. And again, on any of your study guides and online, anything that's usually in bold blue lettering is usually kind of a key point to remember. So, all right. Which type of atmospheric structure can create a path for microwave propagation? A, the jet stream, B, temperature inversion, C, wind shear, D, dust devil. I was thinking jet stream initially until we read through the reason why. Temperature inversions from stalled high-pressure systems often occur in the summertime and can form an atmospheric waveguide carrying VHF, UHF, and microwave signals hundreds of miles within the temperature inversion. So on a hot summer day, there's no local wind. Get on the VHF, UHF bands and work some Tropo DX. And there's a website, dxinfocenter.com, and that's center with an RE. To actually see the tropo ducts live. So B, the temperature inversion. Visual of a tropo duct, a mirage as images are refracted from above to the roadway below. We've all seen that kind of a thing when you're out driving that in a hot day and the heat coming off the pavement and it looks like a mirage. That's kind of your tropo ducting. What is the typical range for tropospheric propagation of a microwave signal? A, 10 to 50 miles, B, 100 to 300 miles, C, 1200 miles, or D, 2500 miles. You see, as we read through before, the correct answer for this is B, 100 miles to 300 miles. So because the troposphere is so low compared to ionospheric regions, it stands to reason that skip distance will also be a lot less for tropospheric modes than, say, F2 ionospheric reflections. Propagation is typically on the order of 100 to 300 miles, but can occasionally be much farther because of multiple hops or mixed mode propagation. So, correct answer is B, 100 to 300 miles. What do Hepburn maps predict? Sporadic E-propagation, B, locations of auroral reflecting zones, C, likelihood of rain scatter along cold and warm fronts, or D, probability of tropospheric propagation. So if you're looking for your probability of tropospheric propagation, check out your Hepburn maps. Answer is D. Since the troposphere is where weather happens, it makes sense that weather prediction can help a lot with tropospheric propagation prediction, and it does. The Hepburn map is a specialized weather map geared just for predicting radio phenomena in the tropo weather zone. Answer is D. And if you go to www.dxinfocentre.com, you can check it out. So great tropical conditions seen on the west coast and the Gulf between Texas and Florida. Go on to our next one here. We're going to keep it moving just because of what happened there with the delay and things already being highlighted. So, how does the maximum range of ground wave propagation change when the signal frequency is increased? Is it A, stays the same, B, it increases, C, it decreases, or D, it peaks at roughly 14 megahertz? Obviously, as your frequency increases, your range is going to decrease. As if you look at any of your bands, obviously, the higher frequency ranges that it's in, essentially the lesser distance you're going to have to cover. Ground waves travel further on lower frequencies, so as the frequency of a signal is increased, ground wave propagation decreases. The same propagation phenomena occurs with audio frequencies. Lower audio frequencies travel further than higher audio frequencies. That's why foghorns that you hear out on the water are always blast out on a very low audio tone. So, correct answer is C, it decreases. Alright, which type of polarization is best for ground wave propagation? Is it A, vertical, B, horizontal, C, circular, or D, elliptical? As you can see here, when we went through initially on the initial video, it is A, vertical polarization is best for ground wave propagation. We use vertical polarization for ground wave propagation. Knife edge bending is a good example of a vertically polarized ground wave that dragged the bottom half of the wave over a mountaintop, resulting in ground wave signal getting into valleys where normally they would be no reception. A. As you can see here, excuse me, you can see a little picture here depicting knife edge diffraction. So between a transmitter and a receiver, and how it kind of takes it and it's vertically polarized to take it over the mountaintop. How should you generally identify your station when attempting to contact a DX station during a contest or in a pileup? Is it A, send your full call sign once or twice, B, send the last two letters of your call sign until you make contact, C, send your full call sign in grid square, D, send your call sign of the DX station 3 times, the words "this is," then your call sign 3 times. And just good radio etiquette, you're going to send your full call sign a couple of times. So the correct answer here, it was A, and this is what their explanation of it for you. Always make sure to send your full call sign when operating DX, not just the last letter or two in your call sign, which is technically illegal. Rules also require that you momentarily listen to your transmit frequency to ensure that the frequency is not in use, so the answer is A. Alright, next question. Why might a DX station state that they are listening on another frequency? Is it A, because the DX station may be transmitting on a frequency that is prohibited to some responding stations? B, to separate the calling stations from the DX station? C, to improve operating efficiency by reducing interference? Or D, all these choices are correct. And as you can see, we already highlighted all of these reasons are correct, and this is why. As a new extra class operator, learn from listening during your first contest in the extra class portion of the band. It is an international contest. You will hear rare DX stations calling for a contact, listening up 10. They are not listening on their own transmit frequency, but are listening 10 kilohertz higher for a response. An example might be a foreign DX station contesting just below your extra class band limits on 20 meters at 14.145. Listening up 10, this means you would transmit you would transmit back to them on 14.155 megahertz. To do this, you would tune your VFO-A to the receive frequency of 14.145 and put your VFO-B on your transmit frequency of 14.155. Now engage split VFO operation and make sure you are transmitting on VFO-B while receiving on VFO-A. You must be in split for this to occur. If you transmit back to the foreign station outside your extra class band privilege, you are illegally out of band and the foreign station can't hear you because they are listening up 10 kilohertz. Split operation reduces interference, separates calling stations from the DX station, and lets the DX station stay in the clear out of the US phone band. So D. All of those choices were correct. That kind of shows. Alright. What is the Cabrillo format? Is it A, a standard submission of electronic contest logs? B, a method of exchanging information during a contest QSO? C, the most common set contest rules? Or the rules of order for meetings between contest sponsors? As you can see, we already kind of went through this. The correct answer here is it's a standard for submission of electronic contest logs. I've seen it, if you go into your WSJTX, under your file settings, you can see there where you can import or export your ADIF file. There's also a spot there for your Cabrillo log. And that's where I've seen it before myself. The various computer logging programs such as CT by Kilo 1 Echo Alpha, or your TR log, or N1MM log, etc., have built-in utilities that automatically generate a Cabrillo formatted log after the contest is over. It's one of those features where you can click on a box and the program automatically chunks out a Cabrillo file for submission to the contest sponsor. So the correct answer is A. Alright. Which of the following best describes the term self-spotting and a connection with HF contest operating? A, the often prohibited practice of posting one's own call sign and frequency on a spotting network. The acceptable practice of manually posting the call sign of stations on a spotting network. C, manual technique for rapidly zero beating or tuning to a station's frequency before calling that station. Or D, the automatic method of rapidly zero beating or tuning to a station's frequency before calling that station. As you can see here, it's the often prohibited practice of posting owns call and one owns call sign and frequency on a spotting network. And this is why. Most avid contesters looking for a high contest score will stay glued to a computer call sign spotting network. This allows them to see where rare stations are operating on the radio dial. It is considered poor practice to spot yourself on a computer posting of contest activity called self-spotting. So as you can see, it's frowned upon for self-spotting. And we'll move on to our next question here. During a VHF UHF contest, which band segment would you expect to find the highest level of single sideband or CW activity? At the top of each band, usually segment reserved for contest. B, in the middle of the band of each band, usually on the national calling frequency. C, in the weak signal segment of each band with the most of the activity near the calling frequency. Or D, in the middle of the band, usually 25 kilohertz above the national calling frequency. And as you can see here, we've already highlighted C, in the weak signal segment of the band with most of the activity near the calling frequency. During a VHF UHF contest, most of the weak signal sideband activity is found on each side of the calling frequency. These two frequencies are where to hang out looking for a random DX call. Once you make the contact, move at least 5 kilohertz from these channels. And you can see here, he kind of posted the screenshot, 50.125 and 144.200. All right, next question here. From which of the following bands is an amateur radio contesting generally excluded? Is it A, 30 meters, B, 6 meters, C, 2 meters, or D, 33 centimeters? Correct answer is A, 30 meters, and this is why. The 30 meter 10 megahertz band allows CW and data only with a maximum power of 200 watt output. There is no contesting allowed on 30 meter band. So answer is A, 30 meters. Next question here. What is the function of a DX QSL manager? Is it A, to allocate frequencies for de-expeditions, B, to handle the receiving and sending of confirmation cards for a DX station, C, to run the net to allow many stations to contact a rare DX station, or D, to relay calls to and from a DX station? As you can see here, we went through and it's already highlighted. Correct answer is B, to handle the receiving and sending of confirmation cards for a DX station. It's fun going out on a de-expedition, sometimes on a big scale de-expedition. Minding the paper QSL cards and the electronic QSL requests is best handled by a DX QSL manager. They carefully check the logs to ensure all of the contact information is valid and then send out the converted QSL card confirmation. It is a huge job, so you know a DX QSL manager, give them a pat on the back. Answer is B. So again, if you're catching in late, a lot of these are already highlighted because I recorded everything previously and lost audio through all the question and answer portion of the video, so I had to re-record back through. So, and this is the last question for this section. Which of the following contacts may be confirmed through U.S. QSL Bureau system? Is it A, special event contacts between stations in the U.S.? Is it B, contacts between U.S. station and a non-U.S. station? C, repeater contacts between U.S. club members? Or D, contacts using tactical call signs? QSL bureaus are very busy. Don't load them down with U.S. QSL Bureau with domestic QSLs. These bureaus are set up to handle the special mail requirements between U.S. and non-U.S. DX stations, both incoming and outgoing. Correct answer is B. So the U.S. QSL Bureau system is for contacts between U.S. stations and non-U.S. stations. So that finishes up our second session of all the question pools we've gone through. So far we've completed basically all of the rules and regs question pool section and gotten in through and finished up the Skywaves and contesting section. So The next video that we shoot and go through most likely would be another live stream of the question pools, and we'll start off right here on outer space comms. That's our next question pool. So fun little thing to see here. So that's our next section that we'll be going through, and I appreciate you joining in. And well, thank you everybody for stopping in and going through with me, and I apologize for a little bit of a confusion there. I usually going through the questions and answers real time and highlighting as we go, but again I had to re-record because I lost audio, so bear with me on that, and hopefully the next one will go live stream. I chose not to do this one as a live stream because today's Super Bowl Sunday for 2021 and didn't think there'd be a whole lot of participation with folks. So with that, I hope everybody enjoys their day, and as always, get on the air.